Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the unit I'm going to discuss is about applications of smart sensors and devices, and the topic which we are going to discuss now is terahertz sensor. So we all would have heard about this term, that is terahertz sensors. So this normally operate in the electromagnetic spectrum between the microwaves and infrared, and the range is of from zero point 0.1 to 10 terahertz. So this unique band enables us for non-contact, non-ionizing and high resolution sensing. So this makes the terahertz sensors highly valuable in advanced engineering and research applications. So they provide sensing capabilities across the variety of fields such as material characterization, imaging, security applications, etc. In case of the aerospace domain for manufacturing the components, these terahertz sensors are vital in identifying any defects, subsurface defects in those manufacturing components. So here the frequency range is from zero point 0.1 to 10 terahertz. So now understanding the empathy part of this terahertz sensors. So we have to understand the sensor technology, how it plays the role in various application. So what happens is a terahertz source will generate this terahertz radiation, which is non-ionizing. So for this, they make use of this antenna, the laser or any frequency multipliers. So this will interact with the target material, and that will absorb and reflect its molecular structures. So this process, identifying the technology of this process is challenging, and the impact of these terahertz sensors on various industries, like how it enhances the accuracy and innovation. And also, this is acting as a good breakthrough for exploring new avenues for research and discovery. So, the person who is making use of working under this domain, this is safe, unlike other traditional methods like X-ray and ultrasound. Terahertz sensors, they are safe, they are non-ionizing. So how we can define the terahertz sensor? So this is it lies between the electromagnetic spectrum for microwave and infrared in the range of zero point 0.1 to 10 terahertz. And the applications are they are used in multiple fields. So one example, as I told, it is in the communication, telecommunication part, security, screening, aerospace domain, the manufacturing of those components, in error detection, etc. So there are a lot of applications of these terahertz sensors. So now let us talk about this working principle of terahertz sensor. So the terahertz sensor, we can see that it can be generated using the first is generation methods. So this can be generated using various techniques like photoconductive antennas, optical rectification, etc. So the terahertz source will generate the terahertz radiation, so as photoconductive antenna, or we can use a quantum cascade laser or any frequency multipliers. So these terahertz wave will interact with the target material. So the material absorbs or reflects the terahertz waves based on its molecular structure. And the detection techniques in this part, detection. So the terahertz detector captures the modified signal, and then the signal processing extracts the time domain or frequency domain information for the analysis. So these are the working principle of this terahertz uh, radiation. So key application, material characterization. So when we talk about the aerospace domain, the defects which are not visible, the subsurface defects would be identified with the help of this terahertz technology. Security screening, that is, this imaging can detect the concealed weapons and explosives. This provides a safe and efficient method for screening individuals and luggage. And the biomedical applications, that is for non-invasive medical imaging, allowing the researchers to study the tissues and cells without damaging them. So this also gives the imaging, medical imaging technology applications. So advantages of the terahertz sensors. So it is mainly for non-destructive testing. So which means that it provides a non-invasive way. So this makes the diagnostic without causing any harm to the source, to the target. And high resolution. So this offers high spatial resolution, making possible to differentiate between the closely spaced features in complex sample. And also faster data acquisition. So this allows for good real-time monitoring and the analysis of the data. So the challenges and limitations. So this main thing is it is having a strong absorption by water vapor, and also it is having limited penetration depth in metals. And expensive sources and detectors are to be used. So the cost is high. The system integration is also complex. So material limitation, complexity, and the cost is limitation of this terahertz sensor. In metal parts, it is limited. The penetration is limited. So the future trends here is we can the integration with other technologies. So for example, this terahertz would be combined with the MRI technologies or the ultrasound for enhancing this diagnostic capabilities and miniaturization. So making it as small as possible, so such that it can be portable, and then industry expansion. So these are the future trends of this terahertz sensor. So today's assessment is the operating frequency range of terahertz sensor lies between zero point 0.1 terahertz to 10 terahertz. Major advantage of terahertz radiation used in the sensor is it is non-ionizing and safe for biological tissues. Thank you.